How widespread is plastic infestation in marine organisms? Hello, friends. Jim here. An article appeared on the phys.org page. Polar plastic. 97% of sampled Antarctic seabirds found to have ingested microplastics. Plastics are found everywhere in the oceans, from the Arctic to the Antarctic, from surface waters to the Marianas Trench, and organisms are ingesting them, whether it's microplastics or nanoplastics. Organisms are ingesting them. I've done numerous videos documenting this with you before. In fact, my most recent one was about microplastics in walruses. So this is a problem because when organisms ingest this material, it interferes with the physiology and basically will lead to higher increased mortality. So this figure here is showing a global distribution of study sites and relative 13 species considered. Red dots are Arctic sites. Right. So let's enlarge this. There we go. So red dots are the Arctic sites, the yellow are the Antarctic sites. And as you can see, we have various birds like mures, auklets, gulls, and so forth, petrels, penguins, right? Adelie, right? Patagonicus, right? So here are the distributions. As you can see, a lot of the sites near the Antarctic Peninsula. So anthropogenic plastic pollution is often experienced through evocative images of marine animals caught in floating debris, but is, of course, more pervasive, more ubiquitous. The polar regions of the Arctic and Antarctic are increasingly experiencing the impact of plastic reaching floating ice and land, not solely as larger macroplastics, which is considered to be greater than 5 centimeters, but as microplastic, which is considered to be in the realm of 0.1 microns to 5 millimeters. Nanoplastics are smaller than 0.1 microns that may be carried vast distances from their source or be ingested in more populated areas during seasonal migration. Now, I have to say a note on the size distribution for categorizing it. This 0.1 microns, I think, is a adjustment, a new adjustment, because I'm used to seeing 1 micron being the cutoff, where if it's smaller than 1 micron, it was nanoplastic, where 1 micron and up to 5 millimeters was considered to be microplastic. So this seems to be a bit of an adjustment, and why, I'm not sure, but that seems to be the new, how they're classifying it. A new review published in Frontiers in Marine Science has investigated the scale of this issue, particularly with respect to seabirds who use these regions. PhD researcher David Turozzi and Professor Massimiliano Scalici of Roma Tre University in Italy undertook this project, and they summarized 40 years of research into seabird ingestion of microplastics from 1983 to the present day. Quite extensive and ambitious. Across 1,100 samples, the researchers explored stomach contents, crop pouch near the throat, where food is temporarily stored before further digestion processes. Basically, when the birds go foraging, they just swallow a bunch of stuff to keep it in the crop. Then they worry about either coughing up some of that stuff for their chicks, or actually swallowing it where the gizzard grinds it down, etc., etc. Of course, guano, which is what comes out the other end, and various regurgitated pellets of undigested food. Pellets form the main component of the samples, followed by stomach contents and guano. Pouch contents were minimally present, probably because it doesn't stay there very long. They found that 13 species of seabird inhabiting polar landscapes were reported to have ingested microplastics, including little auks, northern fulmars, glaucous gulls, thick-billed murres, white-chinned petrels, great shearwaters, sooty shearwaters, king penguins, Adelie penguins, chinstrap penguins, gentoo penguins, brown skuas, south polar skuas. So in this figure here, the number of microplastics found in each sample, that's for A. B, for each plastic type. C, the type of polymer. And D is the plastic types per bird. So as you can see, most of the samples came from stomach content. Keep in mind, the red is for Arctic, the yellow is for Antarctic. And again, a breakdown, plastic type, cellulose sheath, thread, foam, film, pellet, so on. And let's see, C, which is down here, is the polymer type. I'm not a chemist, so, well. And then the breakdown by species and what was pretty much they ingested. It's quite a bit. Again, like as always with my videos here, feel free to pause the video and study these figures in greater depth if you so inclined. A total of 3,526 particles were extracted from the seabird samples, equating to at least one microplastic particle in 90% of Arctic samples, 97% for Antarctic. A median of 31.5 and 35, an average of 7.2, 1.1 microplastic particles were found in each sample in the Arctic and Antarctic, respectively. A maximum of 36 microplastic particles were found in a single bird. Regarding plastic composition, 14 polymer types were identified, the dominant form being polyethylene, followed by polypropylene and polystyrene. By the way, back in when thermal underwear was first coming out, a lot of the materials that made up the thermal underwear is made from polypropylene. I don't know how many of you are aware of that. So of these polymers, they were predominantly present as fragments derived from the breakdown of larger plastic objects. Such plastic polymer types can be sourced from items like plastic bags, food, drink containers, and protective foam packaging. The impact ingestion of plastic particles have on seabirds includes blockage of the gastrointestinal tract, toxicity, oxidative stress, as well as triggering immune reactions. Additionally, is not only direct ingestion of particles that is of concern, as microplastics have been found in krill, a food source for some penguins, baleen whales, let's not forget, highlighting the larger scale issue in the ecosystem and trophic webs. You get bioaccumulation, right? It starts concentrating as you move up the trophic levels. Currently, there are 64 and 43 species of seabirds inhabiting the Arctic and Antarctic respectively, but their numbers have been declining over recent years, giving rise to the need for stricter conservation measures, and perhaps cleaning the oceans of the plastics. Considering the Arctic covers about 6% of Earth's surface and is comparatively pristine, not sure about that. The implications of human encroachment on the natural world here can be devastating. Beyond plastic pollution, there are additional pressures of expedition tourism, commercial fishing, maritime routes in the North Sea being used more frequently, and of course, the impacts of global warming on the ice, temperature increases, changes to salinity, sea level rise, and so forth. Anthropogenic impacts on biodiversity in the Arctic and Antarctica are proof that no parts of the planet are immune to the effects of our activities. Thus, concerted strategies to mitigate environmental stresses must be an ongoing conversation. Okay. You can do the breakdown stuff like that. The point is, this stuff is everywhere. It's getting, organisms are ingesting this, and it's killing them. One of the factors that I identified in the portion I wrote about overlooked environmental tipping points. What are some of the factors leading to mass extinction events in the oceans? Well, one of the factors I identify, with a modern day factor, of course, plastic pollution. And it's happening. So it was more trouble for marine organisms. Even though they concentrated here about seabirds, it isn't just the seabirds, it's krill. Whales eat krill. Other fish eat krill. Birds eat krill. Orcas eat some of the fish, they eat some of the krill, they eat the plastic. You get the idea. This gets in the food chain. And remember, we have plastics, microplastics, in humans and found in our blood. This is a ubiquitous problem all over the planet. Land, sea, what have you. And I don't think many species will be able to escape not being impacted by ingestion of plastic particles. There you have it. We'll talk soon.